differentiation. Okay, now today, as we are going to talk about this term differentiation, next term in basic maths. So earlier we did like these trigonometry and all those kind of terminologies. Yes. Now today we are going to exclusively talk about differentiation and slope. Word or not? Okay. And what is called as function and all. So the first term which I am going to bring, uh, you can't see my screen. Uh, just pin that screen. Okay. Pin the present. You just pin the presentation. Okay. Now you can see. Now you can see now perfect, correct written, not the mirror images. Yes. Okay. So let's give the heading about the word called as slope. Okay. Or it has a common name, tangent. Sometimes it is used as tangent in other situations. Now, what is this slope and what is this tangent? Yes, this might confuse you. So I'll take one example. Let's take one example. Let's suppose that my friend is too much rich and like he have gold in his home and all, and I want to steal from him. So what I will do, like let's suppose he kept his some gold chains over here, and let's suppose one person, okay, is walking over here. Are you able to get me or not? Is that clear? Now if this person will walk over here, means you can only think, okay, as this person will walk, got it on, what will happen, he have to climb this particular inclination or not. Yes. And you can feel like, let's take an example, let's imagine something like, let's suppose two lines are like this way, very nearer to each other. Okay, so traveling on this is easy, yes or no? If I travel on this, it's very easy, you can travel easily. Yes. But as you start to increase this particular, let's suppose what I'm doing is, instead of just traveling on one, I just did one thing, that instead of traveling over there, now I started increasing this inclination. When you will increase this inclination, what you will feel? You will feel difficulty in climbing as the inclination is increased further or not? Tell me yes or no. Now you see this inclination, then you see this inclination, and then you see this inclination, and then you see this. Three situations. Let us study three situations. When you see this inclination, after a very long change in x, see, let's suppose this is base is x axis. So after a very long change in x, there is a very small change in y or not? Tell me yes or no. Yes. See, let's suppose I call this vertical axis as y and horizontal axis as x axis. Are you able to get me? So if you can see that as x is increasing, the change in y is very small or not? Correct? Yes. How come? Basically you can see that now, that see how come it is y axis, basically you can see that it's rising very small length in the y axis or not? Yes. So that is change in y. Earlier it was how much? 0. If it is parallel to x axis, it is 0 or not? Then it has some length along y axis or not? So that change from 0 to something is very small as the x rised up over here or not? But when you compare this term, what you observe, x decreased but the change in y has become more or not? Yes. And furthermore, x is furthermore decreased and change in y is increasing furthermore, and that is very fast or not? Tell me yes or no. So idea is simple, that as I change my x, the values of y changes. Why? Because we say that, let's suppose You gave some y as a function of x. Function of x means it's some equation of x, good or not? Implies some equation. We'll talk about this function also a little bit later, but first we'll talk about slopes. Are you able to get me or not? So function of x implies some equation. So y is dependent on x. Now, as x is changing, you can observe that the y is changing for each and every length in a different way. Yes or no? For here, it is very, very fast. Like if I consider this first, this has second, this has third, this has fourth. In the first one, change in y with respect to x. Okay. So I'm finding these changes. So you can see that change in y with respect to change in x is, in first it is very, very more than second, than third, than fourth or not? Tell me yes or no. As x is changing with respect to that, in y it is very, very fast. Yes, in second it is very, very little bit less, in third it is much furthermore less, in the fourth it is less. Yes or no? So the question arises now, how to determine this change? Anything if I want to find with respect to something, that can be given by some physical quantity or some mathematical quantity or not. So we define this quantity as slope, which is denoted as m. It says that how this y changes with respect to change in x. Are you able to get me or not? What is the idea of slope? It talks about how change in y is there, is present with respect to change in x. Are you able to get me or not? Got the idea? So basically you can see that slope is what? Delta y by delta x. For any graph, it is equal to how much? Delta y by delta x. But let us see that. Let's talk about it in a deeper sense. Now let's suppose this is my x axis and this is my, so let's suppose this is your x and this is your y, and a graph is drawn like this way. It's drawn exactly like this way. Are you able to get me or not? Yes. So let us first talk over here on it, then I'll go to that, such that you can understand it in a much more clear sense. 1 minute. See this. So let us talk about this in a much more greater sense. Let me bring one idea. Now let's suppose you have x-axis and y-axis, and the graph drawn over here is looking like this way. Got it? So this graph will, see, if I draw a straight line like this way, that means that it is something of, that means that y is related over x with respect to this graph or not? Tell me yes or no. Yes, means that this graph represents some equation of y with respect to x. Are you able to get me? Yeah, so equation of y with respect to x. So basically you can see that, see how this y is changing. This is my perpendicular y. If I want to find the slope of this graph, I can do now. Like how slope will talk now, that how this y is changing with respect to x. So I can say now that slope is equal to here, this perpendicular y length divided by x. Are you able to get me? But actually, if you look into the graph, nothing is given. Then how to find out? Then we can see that this line makes some angle theta with the x-axis. Yes or no? Now, what is the formula of tan theta? Tan theta is also equal to y by x. Yes or no? 1 minute. Let me check this. Yeah. Tan theta is also equal to how much? Y by x. So basically we can say now that, sir, actually the slope has three formulas. Slope is represented by first m, and it is exactly equal to tan theta, and it is exactly equal to y by x. Are you able to get me? Now you can even think that the question arises now, sir, can we take this theta from this? The answer is no. There is a special way to consider this theta. Theta must be taken from positive x-axis and then rotated anti-clockwise. How to rotate? Anti-clockwise means you have to consider, and see, are you making the notes now, side? No, you have to make the notes. Okay, everything from today onwards, whatever I'll tell, you have to make the notes and write it. Are you able to get me? Weekly once I'll check the notes whether you have made it or not. Yeah, I'll definitely share. You just make the notes, okay? And what point is simple that uh, okay, so you just make it, and whenever you will feel problem, you just ask. Is that fine? Yeah, and make some, see, ultimately, and wherever you have made the notes and wherever you can see that some of the things are given over there, you can just add these things. I'm not saying that write once again. You can see in your older notes, you can study that, you can solve some questions out of that and add these things. Is that fine? Yeah. So theta must be taken from positive x-axis and then rotated in what way? Anti-clockwise. Are you able to get me? Anti-clockwise means this direction. So now look over here. So basically, let's suppose if I consider one situation. Let's suppose the graph is drawn like this way. Okay. But as you can see that it's not perfectly given on x and y axis. Yes. So what we can think about it? We can see something out of it. I can see that this has some length along y and this has some length along x. Yes. See, this point will have some coordinate x1 and then y1 or not. This one will have y2 and this one will have x2. Yes. Then what about, can I create one triangle over here or not? Yes, this triangle. Now look over here, when we can see this triangle, this length is exactly equal to how much? Oh, correct, it is x2 minus x1, and this is y2 minus y1, isn't it? Two of lengths we know. Now you can see that these over here, if we can see, basically when we try to join this line with the x-axis, we can see that clearly that yes, this line can meet with the x-axis, yes or no? Correct. So see, and when I make it meet with the x-axis, this angle is theta or not, or that angle is also even theta or not, or whichever triangle I'll consider, that is also theta. Yes, and all this theta are actually same. Are you able to get me or not? So can we say that the slope can be also given as, which is m, which is equal to tan theta? Here it can be written for delta y by delta x, but that is what? Y2 minus y1 by x2 minus x1. Yes, and you can see that here this means that if this theta is lying between 0 degree and 90 degree, what you can see that when this theta is lying between 0 and 90, that means y2 will always increase with respect to x or not. That means y increases with respect to x, and this is why this is called as positive slope. What it is called as? And this is the idea that when you see that any kind of a line makes how much angles with the x-axis? Angle between 0 and 90. That means y2 is increasing with respect to change in x, and we call it as positive slope. Are you able to get me or not? Second idea is what happens when this theta lies between 90 and 180. So if this is my x and y axis, okay, and theta from 90 to 180 means this kind of particular diagram I'll get or not. Yes. Let us make it like this way, such that we can draw a triangle over there also. Now, if we join it, yes, and once again you got a triangle, yes or no? Now you can see over here, once again, let's suppose this is y and this is x and this is x1, x2, y1, y2. Yes, y2 is finally like this way, yes or no? Are you able to get me? Now, when you can see basically for this, when I join with the x-axis, what is this angle? This angle is an angle lying between 90 and 180 or not? Yes. So here also, if I write slope, which is equal to m, which is equal to tan theta, we cannot calculate this. So what I need to consider? I need to consider this angle over here or not. Let's call this as angle alpha. So what alpha can be written as? Alpha can be written as, or theta can be written as what? Nothing but 180 minus alpha. Are yes or no? Total angle is how much? 180. And this is alpha. So 180 minus alpha is theta or not? Yes. So I can write this now. M is equal to tan 180 minus alpha. You know that this lies in the second quadrant. 180 means x axis. Yes or no? So it will remain as it is. Tan. First I'll get tan alpha. Then this is in second quadrant, which is negative. So minus tan alpha. This is my value of slope over here or not? So when theta lies between 0, 90 and 180, what kind of slope I'm getting? I'm getting a negative slope, and this is why for theta equal to obtuse angles, what kind of slopes we have? Negative slopes we have. Are you able to get me or not? When theta equal to acute angles, what kind of slope we have? Positive slopes we have. Are you able to get me or not? Now, if it is minus tan alpha, you can also prove basically this length is what? Y1 minus y2. Yes. And this length is what? X2 minus x1. But formula of original slope is what? M is equal to y2 minus y1 by x2 minus x1. But this is negative over here or not? Why? Because y1 is bigger over here. So what I'll write? Minus of y1 minus y2 by x2 minus x1. So see, again we got the negative slope over here or not? So there are how many kinds of slope? Two, positive and negative. Are you able to get me? Uh-huh. Yeah. Means this one or this minus tan alpha or y2 minus y1? Which one you were thinking? See, so point is simple. Whenever you see the straight line going down, whenever you see that the angle made with the positive x-axis is how much? Obtuse basically. When you extend the lines, then you will use minus tan alpha. Means you will say that the alpha you will consider the interior angle, but you will say that this slope is negative. Are you able to get me or not? Okay, ultimately we can't find out of theta because this is lying between 180 and something. So nothing we will get. We have to get something out of a triangle. So how to consider for the triangle? By considering negative because it was going down. Are you able to get me? So you have means you have to see the diagram basically. Okay, this is why kinematics becomes tough now. That where the velocity is negative, where this is negative, where that is positive. So for that only we can understand with this situation. Are you able to get me? Is this clear? So we got two situations. First one is slope and tangent. Second one is positive slope and negative slope. Is this clear or not? Now, let us do this connection with respect to our uh, dy by dx or something like that. So, I told you that let's talk about this word function. What does the word function means? Now, imagine, let's suppose I have a balloon. Okay, means I have a, let's suppose we have a spherical balloon. Okay, and of radius r. Okay, and and at t is equal to 0, means at time t is equal to 0, there was no air in the balloon. Are you able to get me or not? So let's suppose when we consider the radius of the balloon, okay, what will happen? See, if we will start to pump in some air, so idea is when we pump some air in the balloon, some air in balloon, what will happen? See, so this radius will change with respect to time or not? Tell me, yes or no? Yes. So what happens when we pump some air in the balloon? Radius of balloon changes with time. Okay. And you can also see that the volume of balloon is also changing with respect to time. This concept, the question is that these two things, they are, means we can say now that a common idea will be what? We can say that, sir, radius or volume is nothing but dependent on time as we pump some air in the balloon. Yes, are you able to get me or not? So question arises now that how this radius changes with time, how this volume changes with time. So we need some mathematics to relate radius and time or not. Tell me yes or no. Function is that mathematical operator. Function is what? Mathematical operator. Means mathematical operator means what? It will just establish some plus minus square something like that terms. Heard or not? Okay. So function is that mathematical operator which adds the relationship between these two quantities. Are you able to get me or not? Which are dependent on each other. Are you able to get me? So if I say that if I want to bind them by some mathematics, I will bring function over there. Function means some equation relation. Are you able to get me? So that is why we can say that we can, instead of writing this whole statement, we will say that R is a function of time, means R depends on time by some equation, or volume is another function of time which depends by some equation. No, means function means, see, function is nothing. T is that dependency. R f of t means I'm establishing radius with respect to time by some mathematical operation. You do not know that mathematical operation. It can be given also, it cannot be given also. Are you able to get me or not? Basically, R can be like time also, like in 1 second 1 meter increase. R can be also t square also or not. In 1 second 1 increase, but in 2 seconds 4 radius increase. Are yes or no? So this relation R is equal to T, R is equal to T square, who provides that? That is called as function. So are you able to get me? Now understood everything? So instead of writing that, what we'll say that R is a function of time or volume is another function of time. So we'll say, so this is why it is said function is a mathematical operator function is a mathematical operator which establishes some relationship between the different variables. Can you get it? Can you get me or not? Is it clear? What? Where you cannot understand? Uh-huh. Huh. Different. See, basically, R and T, they are variables or not? Radius and time, they are variables or not? Did you got any value of them? So they are variables. Okay. So when we establish this relationship between these variables, we establish through a mathematical operation called as function. Are you able to get me? Huh, 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 huh. Okay. Means you want to establish some relation, you need to use some functions. Are you able to get me? Okay. 1 minute. Okay. Now, so we got to know about slope, we got to know about function. That functions are mathematical operator which relates some equations, which establishes some equation like r is t square, r is equal to 3, something like that. Means it's just a word balance. Just remember that function is given as a word. जैसे बोलते हैं ना, means we say na like uh, we two persons when they get married together, we call them couple. So what is a couple? You instantly get, okay, they are together. Yes. So this is what is function also. It means that R is dependent on time. Are you able to get me? R is a function. If I say R is a function of time, it means that R is dependent on time. If I say Y is a function of X, that means Y is dependent on X. Are you able to get me or not? Are you able to get me? Clear. So now let us understand what is this differentiation. So after all these things, the differentiation comes. Okay. Why it comes? Let us see that. Now you only tell me, these straight line graphs which we draw, is it really possible in reality that this much straight can be anything? No, it can be anything. Particle, like if I am a particle, if I am Anurag sir, I will definitely try to prove mathematics wrong. I will never ever travel straight, I'll travel like this way. Yes, I can travel like this way or not. But I can travel in a straight line, but that is a optimum situation. Is it a practical situation? Means I cannot always travel in a straight line, na? Okay. So, like if I want to go from here to LN, do we travel always in a straight line? There are many paths or not. So, basically, anything can be traveled in any way. Okay. But we are considering a simplest one. Let's suppose any such dependency y is varying with respect to x like this way. Are you able to get me? Now, see how this graph I have drawn. Actually, here you can see now. See, if any graph I want to draw, so that means that I will have a relation between y and x or not. For to draw a graph, I need relationship between x and y axis. And this relationship between x and y axis is actually nothing but provided by whom? Provided by a function. Because y is dependent on x or not. Tell me yes or no. So remember how to draw a graph also, that is a matter thing. You have, let's suppose if I say Anurag sir depends on too much of good amount of food. So I'll write Anurag sir is a function of food. Are you able to get me or not? So A will be drawn on y axis and F will be drawn on x axis. Is that clear or not? If I say a quantity Z depends on U with some different kind of mathematics. So Z will be drawn on y axis, U will be drawn on x axis. Okay, but this function has a work, that these lines which we plot now, this plotting is done by this function over here. Are you able to get me? Function provides the idea how to plot the graph between y and x axis. Is that clear? So what is the work of a function? That it first establishes the relationship between y and x such that we can draw a graph. That means any graph which we draw is nothing but a equation or a function of x and y axis or not. Correct? So we'll write any equation which is dependent to each other can be plotted as curve given by some function. Are you able to get me or not? Is that clear totally? So now let's suppose this is my curve and here I can see that. Now you only tell me, earlier in a straight line we can see that y is always changing with respect to x, yes? But here I can't see, now here something is happening at every moment of time. Okay, so draw this diagram. You write from differentiation accurately. Draw this diagram, then I'll start. Okay. Is it clear written? Okay. Uh, Now let us start this. So we know that any equation which is dependent on each other can be plotted as curve given by some function. Now here we can see that y is changing instantly at every moment of time. Now every moment of time means what? Like every point it is changing. So to talk about that, like here very small changes are happening in y, then only this graph is appearing or not. So how to understand those small changes? We are drawing the diagram like this way such as to have a clear view. Now we can see that when I see a change from here to here, okay, we can see clearly that suddenly when x was changed in this fashion, y changed from here to here. Are you able to get me or not? So basically to measure this, it is a very hard task or not. We know that for this graph some equation is given, y is equal to f of x, that we know perfectly, but it is very hard task to see this delta change in y and delta change in x or not, and it is very small. So the slope talks about the finite changes, but the differentiation came that let us make a new mathematics. Newton's thought that let us make a new mathematics which talks about a small changes. So differentiation is based on which kind of changes? Is based on small changes. Are you able to get me or not? And now that small changes was given a name called as infinitesimal. Now you might have seen I am using these words many times in the class. Yes. What is this infinitesimal change? So infinitesimal change is that change means, like, see what is, you know now that what is the word infinity means? Very large. Now let's suppose if I define any quantity 1 by infinity, what it is? Uncountable, and it is very small or not? 0.0000000 something like that. Yes. Yes or no? So we define this 1 by infinity is called as infinitesimal. Okay, means very small. So infinitesimal means what? Very small. Are you able to get me? Which means it is that much small which cannot be counted. That a small change which is nearer to zero. Are you able to get me? So what is infinitesimal change? It means that kind of a change which is nearer to almost zero. Are you able to get me? And that was denoted by a special symbol. This infinitesimal change, like let's suppose if I want to write, let's suppose if I write infinitesimal change in x. So what I will say, it is that change in x which is nearest to zero or not? Tell me yes or no. And that was denoted by a special symbol called as d before the x. So what is dx? Dx means a very small change which is non-countable but nearer to zero. Are you able to get me? Okay, like if I want to say this was infinitesimal change in x. Now if I want to talk about infinitesimal change in y, it will be represented as, tell me, dy. Delta y tends to 0 and it is dy. If I want to write infinitesimal change in time, it is written as dt. So what is dt? What is dt? Infinitesimal change in time. So is it a numerical value, beta? Is it dt a numerical value? No, it's a that value which is very small but nearer to zero, and we do not know that. Are you able to get me? So this is what is the idea about dy, dx, dt and all which we use always. Are you able to get me? Why this was brought? Because in curve at every moment of time this very small changes are occurring. That's why curve is able to bend. Otherwise this curve will never ever bend. It will be like this way. If the curve, if this small changes will not happen, the curve will be like this way, zigzag zigzag zigzag, like this way. Instead it will have sharp turns. Are you able to get me or not? So this is why this differentiation was brought. What is differentiation? Now we can basically, if I want to talk about how y changes with respect to x. So let's suppose if I define a quantity infinitesimal, if I want to know how y changes with respect to it. So I have to find infinitesimal change in y with respect to change in x or not. Which change? Infinitesimal change in x. Change in x. What that will be written as? It will be written as that as dy by dx or not? Yes. So what is this? This is what is dy by dx when you found. What if I write dx by dt? I find the infinitesimal change in x length with respect to change in time. Got it. So what is dy by dx? Change in y with respect to change in x. But what is change in y with respect to change in x? It can be also written na, if delta x tends to 0, it can be written as delta y by delta x. Means if I bring this denominator very small, this is my dy by dx or not? Tell me yes or no. See, point is simple, that How dy by dx came? When delta y and delta x, these changes are brought to nearest to 0 or not? So I should brought by some kind of a mathematics or not, that we call it as limit delta x tends to 0. Bringing denominator nearer to 0, automatically numerator will all come nearer to 0. Okay, got the idea? And this is called as differentiation. This is only called as differentiation. Differentiation is nothing. So differentiation, many people, differentiation, what is differentiation? Arey baba, change in y with respect to change in x at a very small scale. So this is why can we say that differentiation means, in ideal term, in graphical term, differentiation means finding the slope at every point. Yes or no? Because at every point y is changing in the graph. Yes or no? And that is why we know that slope is equal to what? Tan theta. Another formula is delta. Let us write the formula of slope or formula of differentiation. So ultimately m is equal to slope, and that is also differentiation, and that is also equal to tan theta, that is also equal to delta y by delta x, and that is also equal to dy by dx if I want to find the slope of a function given by y is equal to f of x. Got the idea? Simple. Like this curve is there at every point. What is happening? Some changes are happening or not? If I want to measure, I want to find this slope or not. But how to find? See, basically you can't find delta y by delta x all the time, or dy by dx, because it is very small. So what we do, we can directly find the slope over there, which is given as tan theta. Are you able to get me? You have to see if the graph is a straight line or if the graph is curved. If the graph is a straight line, simply delta y by delta x. If it is a curve, then you can't apply na delta y by delta x. Can you apply that? No. So you need to apply dy by dx over there. Are you able to get me? Got that? It is not possible to use dy by dx for the straight line. Dy by dx, it is a constant term or not? So delta y by dy, see, point is, look over here. Dy by dx is only used for the curve cases. Go ahead or not? Because then only we can talk about very small changes. For in this straight line, it is always same or not? Delta y by dl, wherever you will create a triangle, you see that this theta is always same or not? So slope is constant over there. So wherever you find, whether you apply anywhere dy by dx, you will get the same answer. Here, you will never ever get the same answer. Are you able to get me? So let's take one example. I'll talk about examples. Don't take tension. Now, I am representing the speed time graph of a particle, or let us say the distance time graph. And let me write it like this: position time graph. Now, I said the graph is drawn like this way. Okay, and there are some points marked over here. Point A, point B, point C, point D, and let us call this as point E. Question is, identify where the velocity of particle drawn in given graph is positive, negative, or Zero. Do it. Think about it. Imagine it. Then after 5 minutes, I'll tell the answer. A, A is positive, B is hmm, C is zero. And what about A and B? Mm-hmm. B is zero. So how did you understood? We can see the changes, yes or no? And small changes like dy by dx can be represented by a straight line over there or not, which is also called as tangent. Yes, correct. So the idea is simple, that small changes, as you got to know, it is a straight line for that, and that is why this slope is also called as tangent or at any point of curve. So ultimately, let us draw. So first idea is we have to write that we know that sir velocity is equal to displacement by time, yes or no? And displacement by time means what? Simple. If this is position which is represented as, let's suppose this is x coordinate. Which coordinate? X. And this is time, so it can be written as delta x by delta t or not, but it is a curve, so it will change to what? Dx by dt, because delta x by delta t we need to consider very small changes, because every time the velocity will also change. Are you able to get me? Got the idea? So at A, when we draw the tangent which represents the dx by dt, see, as we can see them, okay, as we can see them clearly here, it is pointing up. So slope is positive, because when we connect with the x-axis, this theta is acute. Yes or no? Yes. So here the slope is positive. So basically velocity can be said that velocity is nothing, sir, but slope of position time graph or not. Clear? Is it clear? So here slope is zero because it is parallel, theta is zero. Here negative, zero, positive. Got the idea? Uh-huh. Which one is more positive? Yes, they can ask. We should say D. Yes, correct. Why? Because you see that, let us talk about this. Slope is greater, correct. See, basically, let's pick up one case. There are two cars whose position time graph is drawn like this way. I was going to give you this question right now only. Okay, two cars P and Q are drawn over here, and this is position and this is time. So question is simple: if the position time graph of two cars P and Q is given, then which one moves faster? Tell me, Q or P? Q. Think about it. Think about it. See, analytical answer is, if I am not that much intelligent, my mathematics is not that much great, what I will do? I'll draw a triangle. In which case, the change in, see, basically position means x-axis. X-axis is changing on y length or not, yes? So this is change in x of q. This is change in x of p. And this is time taken by p, and this is time taken by q. Which one is traveling more distance in less time? P. So who is moving faster? So no, it's not about slow right now. It's not about slow. It's about rising of this position. So you might, acha, you are relating this with this idea of this thief problem or what? No, that was just a case. Here, slope is defined as any function, any variable y which changes with respect to change in x. Do not always relate with force and all. It's not about force. Here, this time it will be related with position and time. Are you able to get me? Right or not? Because it is a position time graph. Okay. So now, if this was my idea, see, if I am not aware of slope, then I'll do this. But if I am aware of slope, which one is moves faster? That means I'll talk about velocity. Yes or no? And velocity is nothing but displacement by time. What is nothing but delta x by delta t, and delta x is drawn on y axis, delta t is drawn on time axis. So that means that once again velocity is slope of position time graph or not. Now, so when you find this, and if we know that the formula of slope is given as what? M is equal to tan theta. So see, this is theta of q and this is theta of p or not? Yes? Yes or no? So we can, by looking at the graph, we can say that theta of q is more than theta of p or not? Can I multiply tan on both sides? Sorry. Yes. Sorry. Theta of p is greater than theta of q. Can I multiply tan on both sides? So tan theta of p is more than tan theta of q. And what is tan theta? Slope of p is more than slope of q or not? So if slope is more, then velocity is more of position time graph or not? So that means velocity of p is more than velocity of q. So without even looking, I'll say that velocity of p is more than velocity of q. Are you able to get me? Got the idea? Similarly, here also is we can talk about that. Yes. So let's take one example more. Let's say this is p position, and this is time, and the graph is like this way. 1 minute, sorry. No, it's not good. Alright, why it is going straight? Okay, the graph is like this. Is that clear? Hello, can you hear me? So let us pick up 2 points, point P and point Q. Question is where the speed, select the correct statement. Let me give the correct question. Select the correct option. Option 1, velocity of q is less than velocity of p. Velocity at p or q is more than velocity at p. Option third, velocity at q is exactly equal to velocity at p. Option fourth, cannot say. Which one? Think. What to do over here? Option one. See, right now we define that velocity is nothing but slope of the particle. Yes or no? Slope of position time graph. Yes. Are able to get me? So at these points, I have to think about the slope or not. So how to talk about this is a curve. So what I'll draw? I'll draw tangents to talk about the slope or not. Yes. And the most easiest idea is on that tangent draw a right angle triangle. Trick is what? Draw a right angle triangle, because when you will connect with the x-axis, you will get the same idea. Yes or no? Now, can I mark these angles? This will be called as theta of p, and this will be called as theta of q. So if we look into that, then which theta is more? So if we look into that, theta of p is less than theta of q or not? Yes. Then can I multiply tan theta of p is less than tan theta of q. So that means what? Slope at p is less than slope at q. So which velocity at p is less than velocity at q? So which velocity is more? Velocity of q is more than velocity of p. You yeah. In this I mark the angles. Yes. Huh. So, but it is a curve, na? Can you draw a line over here? See, here if I draw a line, then which one is rising faster? Q is rising. No. Here you can't say anything, na? Because see, here how many graphs were there? Two lines were there, means two cars were there. Here I'm talking about a single particle which is moving. Okay. So that's why I drawn the graph. I compared their time, I compared their distances, but here we cannot compare now. We know that definitely the position is changing, increasing with respect to time. It's a single particle which is moving. So that's why I selected for the single particle where its velocity is more. Understood? Got the idea? Okay. So you have to select where the particle's velocity is more. So now you can imagine now, if it is a one graph, I'm talking about how many particles? One. So you have to draw their slope at every point. If I'm talking about two particles, then like let's suppose if I talk about this, if I just talk about this single graph of q, so then the slope is always constant. So that means the particle moves with a constant velocity. Are you able to get me or not? This theta is always constant or not for q? So particle moves with which velocity? Constant velocity. But this particle only here moves with which velocity? Increasing velocity. Understood the idea? Clear? Now, this was the idea about slope and connecting that with the differentiation and connecting with the tangents. Is that perfectly clear? Now, let us talk about our differentiation properly. So, we have the differentiation. We got to know what is the meaning of differentiation. What do we mean by tangent, slope, and differentiation? Now let us talk about these functions. Okay. Now we know that, see, in mathematics, some ideal functions are already devised. Okay. Like first is we call it as algebraic functions. Okay. If I say y is equal to f of x, can you hear me? So okay, so if I say y is equal to f of x, now if this function is of type, like if I write f of x is equal to x to the power of n or something like that, so I can write now y is equal to x to the power of n. X to the power of n means what? X square plus 2x plus 1, something like that. So these kind of functions are called as algebraic functions. Word or not? And if I want to write its differentiation, so some changes are already defined for it. So if I write dy by dx, then what it is? D by dx of x to the power of n, and it is given as nx to the power of n minus 1. Got it? Second kind of functions are our trigonometric functions. Okay. And let's suppose if I write dy by dx, like one type of a is y written as sin x. Yes. If I write dy by dx, it is given as cos x. Are you able to get me or not? So this is also a function. Second b is y is equal to cos x. Their differentiation is given as minus sin x, not only sin x. C is if y is equal to tan x, then its differentiation is given as cos square x. Mainly we three require, others we'll learn later on. Yes or no? We can learn from the formulas. The third kind of functions are our logarithmic functions. Okay. So if I write y is equal to ln x, this means that this ln, this dependency by logarithmic over here is a function. Right or not? Yes. So if I write dy by dx, it is written as dy dx of ln x, and it is given as 1 by x. The fourth one is exponential. You know that is written as y is equal to e to the power of x, and for that dy by dx is just e to the power of x. Yes or no? Are you able to get me? So this is all about your idea of different formulas of differentiation and all. Are you able to get me? Now my point is clear. So today, as it got delayed, I'll not be able to take 2 hour class. I thought of taking 2 hour class. Okay, but I'll take. Okay, let me just give these formulas, and then I'll give the DPP today. Okay, is that clear?